chapter 2.5, which is on variation. Y varies directly with X, directly proportional is another way of saying varies directly if Y is equal to Kx, where K is called the constant of proportionality. Y varies, so this is direct, inversely with X, or is inversely proportional to X if Y is equal to K over X. Y varies jointly with X and Z if Y is equal to X, K, X, Z. Okay, jointly, inversely, and if we have, say, Y is equal to K n squared over m, we would describe this as Y varies directly with n squared and inversely with m. To write a general formula one, set up the variation. Two, substitute given numbers to calculate K. And three, write the general formula with the numerical value for K. So for example, if I have Write general formula for y varies directly with x given y is equal to 6 when x is equal to 18. So this variation is direct, so y is equal to kx. Substituting, we have 6 is equal to 18 times k. So k is equal to 6 over 18 reduced to 1 over 3. So the general formula we take it from this, y is equal to 1 over 3x. Write general formula for f varies inversely with d squared, given f is equal to 10 when d is equal to 2. So set up your variation. This is an inverse variation. F is equal to k over d squared. Substitute for f and d. So 10 is equal to k over 2 squared. So 10 is equal to k over 4. So k is equal to 40. The general formula, we use this. F is, instead of k, we write 40 over d squared. Write general formula z varies directly with the sum of the squares of x and y. Z is equal to 10, x is equal to 2, y is equal to 6. So let's write our variation. This is a direct variation. Z is equal to k into x squared, the sum of the squares. Substitute real numbers. We have z is 10, x is 2, y is 6. So 10, 6 squared is 36, plus 4 is 40. So this is 40k. So K is equal to 10 over 40, which is 1 over 4. So general formula Z is equal to 1 over 4 x squared plus y squared. Okay, here we go. By the way, all the examples I'm doing are from the homework. The distance that an object falls is directly proportional to the square of the time. So distance is, S is the distance, equals 2k times t squared. Object falls 16 feet. So when S is equal to 16, t is equal to 1. So we need to write our general formula before we can answer the questions. So we have to find k, in other words. So 16 is equal to k times 1 squared. So k is equal to 16. So the general formula is S is equal to 16 t squared. Now let's answer the first question. How far will it fall in 4 seconds? Let's call that part A. And then part B, how far will it fall in 64 feet? So when time is equal to 4, S is equal to 16 times 4 squared, which is 16 times 16, or 256 feet. Part B, how long will it take the object to fall 64 feet? So given S is equal to 64, and S is equal to 16 t squared, we substitute for S in here. 64 is equal to 16 t squared. Divide both sides by 16. We get 4 is equal to t squared, so t is equal to the square root of 4, which is equal to 2 seconds. The elongation of a spring balance varies directly with the applied weight W. So W is equal to, the elongation, E varies directly with W. Given when E is equal to 3, W is equal to 28. So 3 is equal to 28K. So K is equal to 3 over 28. General formula, E is equal to 3 over 28 W. Now we answer the question. When W is equal to 23, find E. So substituting, we have E is equal to 3 over 28 times 23, which is 69 over 28. Okay, this is the way the answer has to be typed in, 69 over 28 as a simplified fraction. Okay, here we go. The volume of gas V held at a constant temperature in a closed container varies inversely with the pressure P. That first sentence tells us the variation. So V varies inversely with P. If the volume of the gas is 2,000 cubic centimeters when the pressure is 200, so V is equal to 2,000 when P is equal to 200. We're going to substitute to find K and write the general formula. So 2,000 is equal to 200 over, K over 200. So multiply both sides by M200. And we get K is equal to 200 times 2,000, which is 400,000. So my general formula is V is equal to 400,000 over P. Now it's asking find the volume when the pressure is 250. So volume is unknown, pressure is 250. So volume is equal to 400,000 divided by 250. Go to your calculator. 100,000 divide 250 to give 1,600. So answer is 1,600 cubic centimeters cc. Okay, let's do a couple more of these. The intensity of light I measured in foot candles varies inversely with the square of the distance from the force. So they tell us intensity is I, they don't tell us distance is what, so we're going to call distance D. And we're told that intensity varies inversely with the square of the distance. Suppose the intensity from a source at a distance 4 meters is 0.095. So when distance is equal to 4, I is equal to 0.095. So we need to compute K here. 0.095 is equal to K over 4 squared. 0.095 is equal to K over 16. Multiply both sides by 16. And we get a value for K here. So 0.095 times 16 is 1.52. So my general formula is I is equal to 1.52 over d squared. Now the question is asking us to determine the light intensity from a distance of 10 meters. So when d is equal to 10, find I. I is equal to 1.52 over 10 squared. 1.52 over 100. And you shouldn't need a calculator for that because all we're doing is taking it 2 places over. So 0.0152 intensity. Okay, foot candles. The kinetic energy K of a moving object varies jointly with its mass m and the square of the velocity. So K is equal to little k, the constant of proportionality, m v squared. And we substitute our numbers. The object weighs 5. Velocity is 10. K, large K is equal to 250, uppercase K. So we substitute these 3 numbers to compute the constant of proportionality. So we've got 250 is equal to 5 times 10 squared times K. So 250 is equal to 500 K. So K is equal to 250 divided by 500, or half, or 0.5. So our equation is, or general formula is 0.5 mv squared. Find the kinetic energy when the velocity is 21 meters. The mass does not change. Okay. If you're traveling on a roller coaster, your weight is still the same, so mass is 5. So kinetic energy is 0.5 times 5 times 21 squared. So calculator, 0.5 times 5 times 21 squared. Oop, wrong. 0.5 times 5 times 21 squared. 11.02.5. Why don't we put that computation in copy that, put it into the notes. Okay, so this is 1102.5. Notice they want the answer rounded to the nearest joule, so 11.1103 would be the answer that you would type in to the MyLab program. All right, one final problem. So this is a question about pipes. The stress in the material of a pipe subject to internal pressure varies jointly with the internal pressure and the internal diameter of the pipe, and inversely with the thickness of the pipe. So what's happening here is we have a pipe, we're looking at it from the side. Carrying some kind of fluid, perhaps water or something like that. We're going to call stress S. Internal pressure, we're going to denote it by P. Internal diameter, we're going to use D. And thickness, we're going to use T. So this is T. The internal pressure acting all around here is P. The diameter of the pipe is D. And the stress on the outside is there. What's happening here is they're trying to compute if this pipe has the correct diameter to carry the amount of fluid. If not, the pipe is going to break. And you probably notice in some areas you see a broken pipe and a lot of water gushing out onto the roadway. That's because the pipe was not properly designed. So let's write the variation. S varies subject to internal pressure, varies jointly with the internal pressure P and the diameter, and inversely with the thickness. Okay? All right, now when S is equal to 100, this is from the problem, D is equal to 5 and T is equal to 0.75. So as you can probably tell, we're going to calculate the value for K. Ooh, where is pressure? Oh, here it is. Pressure is 25 pounds. So 25 times diameter is 5 over thickness is 0.75. So this is 100 is equal to 125K divided by 0.75. So to solve this, we would go ahead and multiply both sides by 0.75. So 0.75 times 100 is equal to 125 over 0.75 times 0.75 K. So 75 is equal to 125 K. So K is equal to 75 divided by 125. Which is exactly 0.06. So I'm going to use S is equal to 0.6 instead of K, P D over T. That's my general formula. Now let's see what they want us to compute. Find the stress when the internal pressure is 35, diameter is 8, and thickness is 0.70. So substitute into this, we have S is equal to 0.6, 35, diameter is 8, divided by 0.70. Okay, calculator. 0.6 times 35 times 8 divided by 0.7 to give exactly 240. So your answer is 240 psi. I'm going to put that calculator shot into the notes. That concludes our lesson for today.